This is Britt Caswell with another example video. In this video, I'm covering example 1 from section 2-7 in the SavvasRealize Algebra 2 textbook. In this example, we are looking at how to determine the number of solutions, specifically in a linear quadratic system. That means it's a system of equations where one is a line and one is a quadratic. So this example starts by giving us this system here, y equals x squared, which I graphed in red, and y equals 2x, which I graphed in blue. So clearly you can see that these two lines intersect twice. All right, that means that there are two solutions. I'm going to show you real quick how to get those solutions by hand, because this one's an easy one. But often you can just use a calculator and look for those points of intersection. So let's take a look at these. You see how these are both equal to y? That means that I can set x squared and 2x equal to each other because they're both equal to the same value. Alright, now when I'm dealing with quadratics I'm trying to solve, I need everything on one side. So I'm going to subtract 2x from both sides of the equal sign so that we have a quadratic in standard form set equal to 0. Now if I'm missing a c term, the easiest way to factor this is to factor out what's called the greatest common factor. So I'm going to look for the biggest value between x squared and negative 2x that I can factor out. In this case it's just an x. So here I get x times x minus 2 is equal to 0. Now if I use my zero product property, I can take each of these factors, the x, and I can set them equal to 0. And if I solve that out, I get x equals 0 and x equals 2. Now I can actually now plug those back in order to get y values. So I'm gonna plug them into the red one, just because that one's quick. So I have y equals 0 squared, and therefore y equals 0. And here I get y equals 2 squared, therefore y equals 4. So my two solutions are at 0, 0, and at 2, 4. And look, if you check it out, here's 2, 4, and here's 0, 0. Now this next question is actually kind of just asking about really just the maximum number of solutions you can have or the minimum number of solutions. So I'm just going to draw 3 of these. Now this really cruddy parabola that I'm drawing, alright, pretend that that's x squared. I just don't know how to draw. So y equals 2x, that's a line that kind of goes like this. Alright, so it's going to intersect it at 2 points. So that's if my b value is 0. Okay, so you see how there's two solutions. Now I can pick like a really negative b value, right? And if I pick that really negative b value, I have 0 solutions. But there is also some kind of b value. I don't know what it is in this case. I'm going to call it its unknown. But it can produce one solution, because it can just touch it just in one spot and move away. We call that being tangential. I don't know what it is for this case, but that is a possibility as well. So that b value, shifting the line up and down here, it can get us 0 solutions to where they never intersect, 2 solutions where the line crosses twice, or it can be tangential, which will produce one solution. So then on this part of the example, we have these two expressions and we're just figuring out the number of solutions, the number of real solutions being the big deal here. So y equals 3x squared, I graphed that in red. Y equals 3x minus 2, I graphed that in blue. And if you notice, these don't intersect at all. So there are 0 real solutions. That being said, there are going to be 2 imaginary solutions because it is a quadratic. But there we are. That's how we determine the number of solutions using a graph. Until next time.